problem statement, long-term measurement and monitoring of air pollutant for hive productivity and honey yield correlation has not been done yet. Objective for this paper, first is to design a monitoring system, and then to develop a monitoring system for this stimulus bee project. Then from the data to produce a correlation analysis between various level of air pollutant with the amount of stimulus beehive health quality. And then our main objective is to help beekeepers or user maintain control. Okay, check the system architecture. This is the system that we use. Hardware and application. This is some example of our wireless node that already attached to the beehive. Stimulus beehive. Okay, this main component. What is the main component there? First is operating board. Act as a body that control the action of other component, and then run the system and reach the necessary data to the user. And wireless module number 2, using LoRaWAN wireless communication system between each node and base station. And then sensors, we currently using a DHT11 for temperature and humidity reading, and for air quality we're using MQ135. Next is a base station or gateway, a single stand wireless node that serves as a receiver. And then a cloud database, provide backup and access stimulus beehive information and send the collected data to the cloud. User can access all data concerning stimulus beehive from anywhere via internet. Next is a power generation. Our system know the dependent free power source, which means we're using solar power. So there's no issues about power outages. This means entire node in our system will operate 24/7. Okay, next a system implementation. Okay, our experiment set up with 3 different type of hive category. First is a healthy hive. Refer to the expansion of pod pollen in the hive in excess of 70%. And we can also say that population of the stimulus beehive are very high. Number 2 is medium healthy hive, rate of around 30% to 70% expansion. Still we can say active hive, but with a low stimulus bee population. And the last and the least is the least healthy hive, just less than 30% pod pollen. The population of the hive level are really low for the colony's activity. Okay, so what we got is first is temperature humidity. We take a look at this data. The temperature around this stimulus beehive for healthy hive, not number 1. Highest temperature record is 32.2 degree, and lowest temperature is 24.7 degrees. For humidity, 95% for the highest reading. For the lowest was recorded as 60%. What we can say here, healthy hive covered with the largest tree. We can see the picture over here. Lots of trees surround this hive. So the hive is in the shade of the largest tree. Okay. The influence of this tree and the shade also has a good effect to the humidity. Okay, note number 2 refer to the medium healthy hive. The highest temperature 34 degree. For the lowest 24.7 degree. For humidity, highest 74% and lowest 21%. We can discuss here this hive located in semi-open area. Temperature reading between healthy hive and medium healthy hive is not very significant, but humidity readings are really significant. Medium healthy hive surrounding area is drier during the day due to lack of tree shade. Note number 3, least healthy hive. Highest temperature shown 46.9 degree. Lowest temperature got 34 degree. Highest reading for humidity 94%, and the lowest reading for humidity is 29%. Based on observation, this hive located on the open field area causes sunlight to radiate directly toward the hive. There are three type of gaseous element that we collect the data. Number 1 is carbon monoxide, CO. Number 2 is carbon dioxide, CO2, and as well as ammonia, NH4. All gases are read in unit of part per million, ppm. The healthy hive graph for CO, CO2, and NH4. CO show highest reading rate 37.8 ppm, and the lowest is 22.8 lowest. Okay, for CO2 reading, for the highest is 2169 ppm, and the lowest is 1181 ppm. For ammonia, NH4, the highest level is 70.9 ppm, and the lowest is 13.3 ppm. Here is the least healthy hive graph. CO highest reading rate 37.8 ppm. Lowest reading rate is 28.2 ppm. CO2 2523 ppm level. Lowest is 1608 ppm. NH4 highest level is 17.9. Lowest is 13.3 ppm. Healthy and least healthy hive show that the level of CO and NH4 are normal. Okay, does not exceed 50 ppm reading because of according from NIOSH standard permissible exposed limit PEL for CO and ammonia is average 50 ppm. However, reading level for CO2 show to be higher than the normal state level of 400 ppm. Okay, there are many ways that animal agriculture can produce CO2. Of food crop. Number 2 is chemical fertilizer usage, and the last is cutting of grass. Conclusion: the influence of temperature and humidity on the health of stingless beehive and colony is very significant, but the effect of air quality in this study is still in search. This paper design, development, and test of a real-time air pollutant measurement and monitoring system. Sensor to measure the temperature, relative humidity, CO2, and NH4. Yes, data is successfully sent to responsible network server process. The main objective to help beekeeper to sustain control.